Okay, so in this question, we're looking at the SEC 2018 Leaving Cert Higher Level Maths Paper 2, Question 5. It says a line 2x plus 3y plus 1 is equal to 0 is parallel to a line 2x plus 3y minus 51 is equal to 0. Verify that A minus 2, 1 is on M, so it's on this line. So this is very similar to the 2019 circle question, where we have a point and we know for a fact it is on the line. Well, if it is on the line or on an equation or on a circle, if I sub it in for x and y, so x and y, it should satisfy the equation. What that means is it should make sense at the end when I multiply it out, and it does. So therefore it is on the line. Find the coordinates of B, the point on the line N closest to A, as shown below. Okay, well, this is a little bit more difficult. I'll fit it all in. So the question is, it is on N, this line that is given, this point B. We know the coordinates of A, and we know everything about M, the line M there. So to find where they've actually helped us out an awful lot, this dotted line here, this perpendicular distance, that's a bit of a hint, because if we could find the equation of this green line here, this dotted line, we could then find B by doing a simultaneous equation between this line and that line there, N. So how do you find the equation of this dotted line? Well, we need a point on that line and the slope of that line. Fortunately, I have a point that is already on this line. That's A. Now, how do I find the slope of this line? Well, I know it's perpendicular to the slope of M. So how do I get the slope of M? I'd recommend changing it to y equals mx plus c form. Okay, so find the slope of, now I actually went and found the slope of this line, but it would actually work out to be the same slope because they're parallel. It said that they're parallel as well. So change it to y equals mx plus c form. I've managed to get, by subtracting 2x and adding 51 to both sides of this, down to here. And I want to get a single y on its own. How do I get a single y on its own? I divide everything by 3. So I now know the slope of this line here is minus 2 over 3, and look, it's sloping downwards, it's definitely a minus. So I invert and multiply by 1, okay, or flip it upside down and change the sign. Invert and multiply by minus 1, or flip it upside down and change the sign to get the slope of AB. So I have the slope of AB and a point on AB. So I can use y minus y1 is equal to m by x minus x1, where I'm using this is my x1 and this is my x2. The reason I'm choosing that point A is because it is on the line AB. Okay, so I have the equation of the line AB here. That is this, the equation of the line AB. So how would I find where the line N and the line AB hit each other? How would I find that point? You've been doing this in second year. You do the simultaneous equation. Okay, so simultaneous equation. What have I gone and gotten rid of? Hold on a second. 2x plus 3y minus 51 is equal to 0. That's N. And the equation of AB is 3x minus 2y plus 8 is equal to 0. I came down to here, so started working downwards. I multiplied equation 1 by 2, and I multiplied equation 2 by 3 to get the y's to cancel. 6y minus 6y is 0, so I'm getting 13x is equal to 78, and then divide by x to get, divide by 13 to get x on its own. Once I have x on its own, I've gone and used this over to here to try and get y on its own. So I manipulated it to get y on its own and then filled in what I know the x was. And nice to finish it off by saying x and y, finish it off by actually giving the coordinates of point B there as asked. And the last part of the question is where the circle comes into it. So it's a line and a circle question. Two circles S and T are shown in the diagram. M is a tangent to S at A. So this point here, A, that we already knew. What were the coordinates of A? -2, 1, and B was 6, 13. So that's a tangent, and N is tangent to T at B. Find the radius of S. Sorry, the ratio. Jesus, I read that wrong. The ratio of the radius of S to the radius of T is 1:3. So if this was 1, this distance would be 3. And that ratio holds up for the diameters as well. So if this was a distance of 1, this would be a distance of 3. So we're looking for it to be split. These 2 points get split in the ratio of 1:3. Find the equation of S. Okay, so that's this circle here. What do I need to find the equation of a circle? I need the center and I need the radius. So first of all, I want to find this point C that I have labeled, okay? So I know C splits A and B in a ratio of 1:3. So it's important to go to our log tables and perfectly write this formula out. The log tables also notes that the ratios should be written as 1:3, and then you're labeling them A and B. Okay, that's really important that you're labeling them in that order. Also important, go and label them x1, y1, x2, y2. Fill into the point splitting a line segment in the ratio and multiply it out. And we get C is 0, 4. Okay, so C is 0, 4. So a little bit more, we have -2, 1. I have 0, 4. And I have a circle. So what else do I need? I need the center. Well, how do I get the center? The center is going to be the midpoint between 0, 4 and -2, 1. So in red here, P is the midpoint of AC. And I'm just using the midpoint formula there. So I'm getting the average between -2 and 0. What's the average of -2 and 0? Would be -1. And what's the average of 1 and 4? Be 2.5. So it's -1, 2.5 is the center. That's really important. That's going to be my HK later on in a second. What else do I need to find? I want to find my radius as well. So there's 2 ways in which you could find the radius. You could find the distance between those 2 points. That would get you your diameter, and then you could half it. Or, as I said, this was -1, 2.5. You could find the distance between here and here by using the distance formula, and that would be the radius. That's actually what I've done here. I've found the radius straight away without finding the diameter by using the distance formula. You really should be able to do that. x1, y1, x2, y2. So x1, y1, x2, y2. Fill it into the distance formula and multiply it out, and you're getting your radius there. Okay. Now we want to put that into the equation of a circle because we know our radius and we know our center. So our equation of a circle, general equation of a circle, we know our h and our k. Our radius is √13 over 2. Squaring the whole thing out then. Yeah, really take your time. I suppose I've done a little bit of multiplying out coming from here to here, but not much. And then I've taken quite a jump. So I would go x by x is x squared, x by 1 is 1x, 1 by x is 1x, 1 by 1 is 1, and those 1x and 1x gives us the 2x. Y by y is y squared. Minus 2.5 by y is minus 2.5. Minus 2.5 by y is minus 2.5, which gives 2.5y, which gives us the minus 5y. And minus 2.5 and minus 2.5 is 25 over 4. We can multiply. Actually, it wouldn't multiply everything. I'd rearrange. So I have it as x squared, y squared. the 2x coming from there, the minus 5y coming from there, and the 25 over 4, it's going to be minus 13 over 4. If you put that into your calculator, it will give you 4, so it works out to be really nice. All in all, you'd probably be a little bit annoyed that there wasn't more a coordinate geometry line question on its own, and then just a coordinate geometry the circle question, but really doable all round. The marks going for it was 10 marks. 10 marks. That's scandalous. 10 marks out of 600. 10 marks out of 600. What's that? 1.6% of your maths result. 1.6% of your maths result on that question right there. Really, really easy. Another 1.6% from finding B, all from coordinate geometry, the line. Really, really easy. That means only 5 marks going for the circle question, which is the one that took the most time. But not, like, look, take the points where they're going. You'll be pretty happy with it anyways. Hopefully you found the question useful and video useful anyways.